Assalamualaikum warahmatullahi wabarakatuh. My name is Alfi, Azaria, Roja. I'm from Group 6 Derivated. In this video, I will tell you about the chain rule.
In the second subchapter, I will explain about the chain rule. What is the chain derivative rule? The chain rule is a fundamental rule used to calculate the derivative of composite function. A composite function occurs when one function is applied to the result of another function. For instance, if fx and gx are two functions, then the composite function is hx equals fgx represent the chain rule. Application of chain rule rules. The chain rule is to calculate relates to the derivative of the composition function when you have function that consists of other functions. Chain rules allow us to calculate the whole derivative against an independent variable. This concept is useful when a function depends on the outcome of another function. Chain rules provide a tool to understand how change in one function can affect change in the related function. This is the chain rule formula. If h equals fgx, then the derivative h single quote x again is given by h single quote x equals f single quote gx times g single quote x. hx is the composite function fgx. F single quote x is the derivative of x with respect to x evaluated at x equals gx. G single quote x is the derivative of g with respect to x. Application in simple example. Number 1. Suppose fu equals root u and gx equals 3x plus 2. Determine the derivative hx equals fgx with respect to x using the chain rule. The solution is, first you must calculate the gx. Gx equals 3x plus 2. And then calculate f single quote u. F single quote u equals 1 to root u. In number 3, we calculate the g single quote x. G single quote x equals 3. And then apply the chain rule. H single quote x equals f single quote gx times g single quote x. H single quote x equals 1 divided by 2 root gx times g single quote x. And then h single quote x equals 1 divided by 2 root 3x plus 2 times 3. Therefore, the derivative hx with respect to x is 3 divided by 2 root 3x plus 2. Let's go to the example number 2. The composite function is gx equals parenthesis 4x plus 1 square root. The question is find the derivative g single quote x using the chain rule. The solution is 1. Identify the function u equals 4x plus 1 and g u equals u squared. Solution number 2 is calculate the derivative of each function. Du for dx equals 4. And then dg divided by du equals 2u. And then apply the chain rule. G single quote x equals dg divided by dx equals dg divided by du times du divided by dx. G single quote x equals to square root 4x plus 1 times 4. And the answer is G single quote x equals x parenthesis 4x plus 1. We go to the example number 3. The composite function is hx equals parenthesis 3x minus 2 to the power of 4. The question is determine the derivative h single quote x using the chain rule. The solution is first identify the main function. U equals 3x minus 2 and hu equals u to the power of 4. And then we calculate the derivatives of each function. Du divided by dx equals 3 and dh divided by du equals 4u to the power of 3. And then we apply the chain rule. H single quote x equals dh per divided by dx equals dh divided by du times du divided by dx. H single quote x equals 4 parenthesis 3x minus 2 to the power of 3 times 3. And the answer is h single quote x equals 12 parenthesis 3x minus 2 to the power of 3.